What if I told you there was a way to predict the fate of every civilization, including our own? A single measure that determines whether a society thrives, conquers the stars, or fades into cosmic obscurity. In 1964, Soviet astrophysicist Nikolai Kardashev posed a question that could redefine humanity's place in the cosmos. How do we measure the progress of a civilization? It wasn't wealth, military power, or even intelligence that concerned him. It was something far more fundamental: energy. Every advancement in human history, from the control of fire to the splitting of the atom, has been tied to our ability to harness and manipulate energy. Energy dictates how far a civilization can expand, how efficiently it can sustain itself, and ultimately how powerful it can become. Kardashev theorized that any sufficiently advanced civilization, human or otherwise, would leave behind a clear signature: the scale of energy it consumes. His idea didn't emerge in a vacuum. In 1963, Soviet scientists detected a mysterious radio signal from deep space, one that flickered unpredictably, unlike any known cosmic object. The source? CTA-102, a quasar over 8 billion light-years away. At first, it seemed like a beacon, perhaps a deliberate transmission from an advanced extraterrestrial species. But as the data accumulated, the excitement faded. CTA-102 wasn't a signal from an intelligent civilization. It was something even stranger. A quasar, an intensely energetic galactic nucleus powered by a supermassive black hole. For many, the discovery was a dead end. But for Kardashev, it was a revelation. If intelligent civilizations existed, they wouldn't necessarily send out deliberate signals. Instead, their presence would be written into the fabric of the universe itself, detectable by the sheer scale of their energy use. This realization led him to propose a new way of classifying civilizations. A Type 1 civilization would be one that harnesses all the energy available on its home planet. A Type 2 civilization would control the power of an entire star. A Type 3 civilization would extract and utilize energy on a galactic scale. The higher the number, the more godlike the civilization becomes. Kardashev Scale was initially seen as an interesting theoretical model, but not much more. It wasn't until Carl Sagan expanded on the concept, refining it into a continuous, logarithmic scale, that it became widely accepted. This allowed scientists to place civilizations between Kardashev's categories, including our own. And here's where things get sobering. More than half a century after Kardashev's work, humanity hasn't even reached Type 1. By Sagan's calculations, we rank at approximately 0.73 on the scale. Still largely dependent on fossil fuels, still divided by national boundaries, still struggling to control the very forces that shape our future. But if the scale is a roadmap, it also raises a troubling question. What if most civilizations never make it past this stage? If the jump from Type 0 to Type 1 is as perilous as it seems, could this be why the universe remains silent? The journey to planetary mastery isn't just about technological advancement. It's a race against self-destruction. A Type 1 civilization has complete control over the energy resources of its home planet. The winds, tides, geothermal heat, and solar radiation. All of it would be harnessed efficiently and sustainably. Energy scarcity would be eliminated. Humanity's reliance on fossil fuels, with all its economic and geopolitical consequences, would be a relic of the past. But right now, we're nowhere near that future. Today, humanity's total global energy consumption is roughly 18 terawatts. By Carl Sagan's adaptation of the Kardashev scale, we rank at 0.73. To reach full Type 1 status, we would need to generate at least 10 to the power of 16 watts, thousands of times our current output. The question isn't whether it's possible. The question is whether we will survive long enough to get there. The transition will require breakthroughs in energy production, distribution, and planetary infrastructure. The most promising candidate for closing the energy gap is nuclear fusion, a process that replicates the sun's power by fusing atomic nuclei together. Unlike nuclear fission, which produces radioactive waste, fusion is clean, virtually limitless, and incredibly efficient. Experimental reactors like ITER in France aim to make this a reality within the coming decades. Beyond fusion, humanity would need to develop space-based solar power. Vast orbital solar farms that collect sunlight unobstructed by the atmosphere and beam energy down to Earth via microwaves or lasers. Such technology is already in development, with China planning to launch a solar power station into orbit by the 2040s. On the ground, a fully integrated planetary smart grid would be necessary to distribute energy seamlessly across the globe, ensuring no region is left behind. But technology alone won't get us there. The shift to a Type 1 civilization isn't just a scientific challenge, it's a political, economic, and existential one. Humanity would need global-scale coordination to manage energy resources, regulate consumption, and prevent catastrophic competition over power. And this is where the real danger lies. History is filled with civilizations that collapsed under the weight of their own expansion. The same forces that allow societies to grow. Technological power, resource control, and global interconnectedness can also lead to their undoing. The Great Filter hypothesis suggests that most civilizations never make it beyond this stage. Some exhaust their planet's resources before developing the technology to sustain themselves. Others unleash forces they cannot control, whether through nuclear war, climate collapse, artificial intelligence, or biotechnological disasters. Even if we avoid outright extinction, controlling a planet's entire energy output comes with risks we may not yet understand. Weather control, climate engineering, and atmospheric energy manipulation could bring unforeseen consequences. What happens if a civilization attempting to control its environment accidentally destabilizes it? Could a global energy infrastructure become a tool for oppression? A system of power, both literal and political, that dictates the future of every human being? And here's the great irony: the very technologies that have propelled us towards Type 1 status, industrialization, fossil fuel consumption, rapid technological growth, are also the forces that could destroy us. The Industrial Revolution, which set us on this path, also created the existential threats we now face. The question isn't just how we reach Type 1. The real question is whether we can get there without self-destructing in the process. And even if we succeed, would humanity remain the same? A world where energy is completely controlled, where planetary forces are dictated by human hands? Would we still be human, or would we become something else entirely? Because if we do make it, what comes next is even greater. Beyond planetary control lies something far more ambitious: the power of a star. If humanity survives the perilous transition to Type 1, the next step is even more ambitious: harnessing the full energy output of a star. A Type 2 civilization is no longer confined to its home planet. It has mastered the forces of its solar system, extracting energy at an almost unimaginable scale. At this level, a civilization no longer worries about dwindling resources or planetary catastrophes. The sun itself becomes its power plant. But how does a civilization achieve this? In 1960, physicist Freeman Dyson proposed one possibility: an enormous structure that could capture nearly all of a star's energy. Today we call it a Dyson Sphere. In its ideal form, this would be a shell that completely surrounds a star, absorbing all of its radiation. But this concept, while fascinating, runs into severe engineering problems. No known material could withstand the gravitational and thermal forces required to construct a rigid sphere around a star. A more feasible alternative is a Dyson swarm, a vast array of orbiting solar collectors harvesting energy and transmitting it to planetary stations or space-based infrastructure. Unlike a rigid shell, a swarm could be built incrementally over centuries, starting with satellites and expanding outward. Yet energy collection alone isn't enough to classify a civilization as Type 2. At this stage, society would actively manipulate its star and the solar system itself. This could involve stellar engineering, such as extending the lifespan of a dying star by controlling nuclear fusion processes within it. Some theorists suggest that a Type 2 civilization might move planets, adjusting orbits for optimal resource extraction or even constructing entirely artificial worlds. But could we detect such a civilization if it existed? In 2015, astronomers studying KIC 8462852, Tabby's star, noticed something strange. Its brightness dimmed in irregular, unpredictable patterns, unlike any known planetary transit. Theories ranged from comet swarms to interstellar dust, but some wondered, could this be evidence of a Dyson swarm? A partial megastructure blocking the star's light? No definitive answer has been found, and mainstream explanations favor natural causes. But the possibility remains, which is, if a Type 2 civilization is out there, its excessive energy use should be visible in the infrared spectrum, a fingerprint of its vast power. But there's a troubling question. If Type 2 civilizations exist, why don't we see them everywhere? If they truly harvest the energy of stars, their presence should be unmistakable. The silence of the universe is unsettling. It raises the possibility that most civilizations never reach this stage. They either collapse at the Type 1 threshold or face an even greater danger we have yet to understand. Because beyond mastering a single star, the next step requires something even more unimaginable. A Type 3 civilization wouldn't just control one star. It would command the energy of an entire galaxy. A Type 3 civilization is not bound to a single solar system. It moves beyond planets, beyond suns, and into the realm of galactic scale engineering. At this level, the very definition of intelligence changes. A Type 3 civilization would harness the energy output of hundreds of billions of stars. Every planet, every asteroid, every black hole, all of it becomes a resource. But how would a civilization even reach this stage? If a Type 2 society can already sustain itself with stellar energy, why would it need to expand further? The answer might lie in long-term survival. Stars do not last forever. Even with stellar engineering, they eventually burn out. The only way to ensure indefinite survival would be to control multiple star systems, securing vast reserves of energy across a galaxy. One of the most widely proposed methods for expanding to Type 3 is the use of von Neumann probes, self-replicating machines that could be launched to other star systems, gathering resources and constructing energy-harvesting infrastructure without the need for direct oversight. These probes, if efficient enough, could spread across an entire galaxy in just a few million years, an instant on cosmic timescales. But would such a civilization be detectable? A galaxy undergoing large-scale engineering should emit excess infrared radiation due to waste heat from its massive energy use. In 2015, researchers at Penn State University analyzed 100,000 galaxies in infrared light searching for this signature. The result? Nothing conclusive. There was no clear evidence of a civilization manipulating an entire galaxy's energy output. That silence is one of the most profound mysteries of modern astrophysics. Maybe a Type 3 civilization wouldn't operate the way we expect. Perhaps they have perfected energy efficiency to the point where they emit little to no waste heat. Or perhaps they have transcended physical energy dependence altogether, operating in ways that are beyond our comprehension. Some theorists speculate that a sufficiently advanced civilization might not even exist in a biological form anymore. They could be digital, operating on vast quantum computers with near-zero energy waste. Science fiction has long imagined Type 3 civilizations. The galactic empire in Star Wars, despite its reach, falls short. It still relies on planetary resources. The Borg from Star Trek come closer, assimilating entire worlds and expanding endlessly. The Forerunners from Halo, capable of manipulating entire star clusters, might be another example. But in reality, there is nothing. If Type 3 civilizations exist, they are either deliberately hiding or they simply don't exist at all. And that leads us to the most unsettling possibility of all. Maybe civilizations never reach this stage. Maybe something stops them. The Great Filter hypothesis suggests that somewhere along the path from primitive life to a star-spanning civilization, there is a nearly insurmountable barrier. If that barrier lies ahead of us, we may never reach the stars at all. Because to move beyond a galaxy, to control the universe itself, requires more than just energy. It requires breaking the very laws of physics as we understand them. If the universe is so vast, and the Kardashev scale suggests that advanced civilizations should exist, then why don't we see them? This is the question at the heart of the Fermi paradox. With billions of stars in our galaxy alone, and even more planets likely capable of supporting life, the absence of detectable intelligent beings is unsettling. One possible answer is terrifying: the Great Filter. The Great Filter is the idea that somewhere along the path from primitive life to a star-spanning civilization there is a nearly insurmountable barrier. Either it lies behind us, meaning that intelligent life itself is extraordinarily rare, or it lies ahead, meaning that most civilizations self-destruct before reaching advanced stages. The implications are stark. If the Great Filter is behind us, we may be a cosmic anomaly, one of the few species to have made it this far. But if it is ahead, it means the vast majority of civilizations that reach our level never survive long enough to become interstellar. Where might this filter be? One possibility is that it occurs at the very beginning: life itself. While the universe is vast, the emergence of life may be an extremely rare event. It took Earth hundreds of millions of years of perfect conditions for life to appear. If microbial life is rare, then intelligent life might be nearly non-existent. The jump from simple bacteria to complex multicellular organisms took billions of years. If this step is exceedingly unlikely, then perhaps the reason we don't see type 1, 2, or 3 civilizations is because there are none. They never had the chance to exist. But there's an even more unsettling possibility. The Great Filter is not behind us, but in front of us. If that's the case, it means most civilizations collapse before reaching type 1, type 2, or type 3 status. And when we look at our own world, that idea doesn't seem far-fetched. The same forces that enable our rapid technological progress also create existential risks. Nuclear war, climate collapse, artificial intelligence, and uncontrolled biological engineering. These are not distant science fiction scenarios. They are real growing threats, and history has already shown how fragile human progress can be. There's another explanation: the silent universe hypothesis. What if the reason we don't detect type 3 civilizations is that they do exist, but deliberately remain undetectable? This is known as the zoo hypothesis. The idea that advanced civilizations might observe us but avoid direct contact to prevent cultural contamination. Alternatively, some theorists suggest that highly advanced species may not need massive energy consumption. Instead, they might have evolved into post-physical beings existing in virtual or simulated realities, or even merged into the very fabric of the cosmos. The Great Filter presents us with an existential question: are we before it or beyond it? If intelligence is rare, we may be among the first. But if intelligence is common and we see no one else, that could mean the future is far more dangerous than we realize. And if the filter is still ahead of us, then the next few centuries will determine everything. Humanity stands at a crossroads. Either we ascend toward the stars, or we become just another lost civilization, wiped out before it ever had the chance to truly begin. But what if we make it? What if we pass through whatever barriers await us? What lies beyond type 3? Could a civilization grow so powerful that it controls not just a galaxy but an entire universe? The Kardashev scale was originally designed to measure energy consumption, but some scientists and futurists have suggested that it might not go far enough. If a Type 3 civilization can control the energy of an entire galaxy, what comes next? Some theorists propose a Type 4 civilization, one capable of harnessing the energy of an entire universe. At this stage, stars and planets are no longer the limit. A Type 4 civilization could manipulate the very fabric of space-time, altering the structure of reality itself. A civilization at this level might not only control black holes, but create them. They might be able to harness the energy of dark matter and dark energy, forces that make up the vast majority of the universe but remain a mystery to us. If dark energy is responsible for the accelerating expansion of the universe, then a Type 4 civilization could, in theory, manipulate cosmic expansion itself. But even that might not be the end. Some theorists have speculated about a Type 5 civilization, one that has transcended the boundaries of a single universe and operates across multiple dimensions or even across multiple universes. If the multiverse theory is correct, then there could be intelligences capable of navigating or even creating new realities. At this level, the concept of energy itself might become irrelevant. These beings might not require stars or matter at all. They might exist purely as consciousness, operating outside the physical constraints of any universe we can understand. Some physicists, including Nick Bostrom, have even suggested that our own universe could be a simulation, one potentially created by an intelligence far beyond our understanding. If that's the case, then the Kardashev scale doesn't just describe energy use. It describes layers of existence itself. If our universe is just one of many, then a Type 5 civilization may not just be advanced. It may be godlike, with the ability to alter or create reality at will. Science fiction has long speculated about such civilizations. The Q continuum from Star Trek, beings with near-omnipotent control over reality, could be considered an example of a Type 4 or 5 species. The entities in 2001, A Space Odyssey, which evolved beyond physical form, might also fit. But the real question is, if such civilizations exist, would we even be able to recognize them? Or would they be so far beyond us that their presence is indistinguishable from nature itself? At this point, the Kardashev scale moves beyond science and into philosophy. What is the ultimate destiny of intelligence? And so, if we measure progress by energy consumption, are we missing something more important? A civilization that consumes galaxies but self-destructs in the process may not be advanced at all. Perhaps the real measure of progress isn't just about surviving or gaining power. It's about how a civilization chooses to use that power. And that brings us back to humanity. We are still struggling to reach Type 1, still grappling with the same forces that could destroy us or propel us forward. The choices we make today, our approach to energy, technology and cooperation, will determine whether we ascend toward the stars or become just another footnote in the silent history of the cosmos. The Kardashev scale isn't just about the future of the universe, it's about the future of us. Because in the end, this isn't just a question of technology, it's a question of survival. Will we pass the test? Or will we fail like all the others?